Welcome to our module on kinematics. What exactly is kinematics? Well, kinematics is the science of motion. So in this module, we'll be looking at objects that are moving. No, Tina. No, this is not your module, okay? Get away, Tina. So, sorry about that, girls, but first thing we'll be looking at are displacement time graphs. But before we get into displacement time graphs, let's look at some basics. First, we need to know some definitions, and these are basically a review of what you had learned with Mr. Broomfield in second form. Distance is how far away from a fixed point or origin something is. Speed is the rate of change of distance with respect to time. So here we have our equation triangle. We know that speed is equal to distance divided by time. Distance is equal to speed multiplied by time, and time is distance divided by speed. It is important to note that distance, speed, and time are all scalars, meaning that their direction does not make a difference. On the other hand, displacement is how far away from a fixed point or origin something is in a particular direction, and its unit in physics is normally meters. What's the difference between displacement and distance? Well, if we look at our diagram here, imagine that you left your home and you walked 3 kilometers to the store, and then you walked 3 kilometers back home. Your distance traveled would be 6 kilometers. It would be simply 3 plus 3. However, your displacement would be 0, because you traveled 3 kilometers in one direction, so that would have been a positive 3, and then 3 kilometers in the opposite direction, that would have been a negative 3 kilometers. Velocity is also a vector. It is the rate of change of displacement with respect to time. Its units in physics is normally meters per second, but it could also be kilometers per hour or parsecs per year. Acceleration is the rate of change of velocity with respect to time. Its units is meters per second or meters per second squared, as it is also said. What exactly is acceleration? Well, it's when you're moving one velocity and then you go faster. It's when you increase your speed or velocity. Some other common units of acceleration could be kilometers per hour per second, or parsecs per year per month. As long as your velocity is increasing, then we say that your acceleration is positive. If your velocity is decreasing, then we say that your acceleration is negative, and in particular, we call that deceleration. Now, let's get into the meat of today's lesson, displacement time graphs. We should be able to interpret them and see what they mean. So, the first kind that we'll be looking at is a graph that is sloping upward in a straight line manner. When that is the case, we say that it is showing constant velocity. Why is it showing constant velocity? Because a straight line going up like that with a positive slope tells us that we are moving a certain amount of displacement with a regular interval of time. If you have a horizontal line, on the other hand, whether high or low, that means you have zero velocity. Why does it mean you have zero velocity? Well, because the displacement isn't changing. The person isn't moving at all, no matter what time it is on the horizontal axis. So if they are not moving, then their velocity is 0. If your graph curves upward like that, where it starts off shallow in gradient and then the gradient becomes steeper and steeper, then that means the object or person is not moving with a constant velocity, but they are indeed accelerating. Why is that the case? Well, when we look at it, for equal intervals of time, at first the displacement was a little, but as the intervals of time get more and more as they progress, then the displacement becomes large. So it is not traveling at a constant velocity, not covering the same amount of ground every unit of time, but rather it is increasing the displacement with every unit of time. On the other hand, if a graph starts off steep, but then its gradient becomes shallow, that means it is decreasing. It is the opposite of what we have here. Moving on, you should know that in particular, the gradient or slope of a distance time graph, or in our case here, a displacement time graph, will give you the object's speed or velocity accordingly. So here in this example, if you travel 20 meters in a time of 5 seconds, that speed will be the change in the distance divided by the change in the time, also known as rise over run. That will give you 4 meters per second. Every second, the object travels 4 meters. So if it started off at 20 meters, then it goes up to 24. After another second, it goes up to 28. After another second, up to 32. After another second, up to 35. And by the 5th and final second, 4 more makes 40 meters. Please note that if the graph slopes downward, then you'll get a negative value indicating that the object is actually traveling back towards its origin. So now let's look at an example. Here we have a displacement time graph. The displacement is measured in meters, the time is measured in seconds. And we have a very basic journey, one with 3 sections. So you are to describe the journey in words. Then you are to determine the displacement when the time is 4 seconds, 9 seconds, and 12 seconds. And you are also to determine the velocity for all 3 parts of the journey. So let's see what the answers for a question like this should be. So if we are to describe the journey's 3 portions, we can start off by saying that the object travels from the origin with uniform velocity for 5 seconds. Being specific, we see it starts from the origin here, where the displacement is 0, and for 5 seconds, it travels a distance of 5 meters. Next, it is then stationary for a further 5 seconds. How do I know it's also 5 seconds? Well, the difference between 5 and 10 is 5 seconds. And finally, it travels with negative uniform velocity back to the origin within a time of 2.5 seconds. That is the difference between 10 seconds and 12.5 seconds. Next, what is the displacement at the time of 4 seconds? How do we determine that? We go to 4 on our horizontal axis, which is the time axis, and we read off the corresponding displacement value on our vertical axis. That corresponds to 4 meters. When the time is 9 seconds, then that corresponding value is 5 meters. And finally, when the time is 12 seconds, then that corresponding time is 1 meter. What is the velocity for all 3 portions of the journey? Well, we use our slope formula, our gradient formula. It's the rise over the run. So we see that it goes from 0 meters up to 5 meters, and then we divide that by the time it takes, which goes from 0 up to 5. So this first one is easy. 5 divided by 5 gives us just 1 meters per second. Here it is very important that you have your units. If you do not have your units, I will subtract half a mark from your work. The units are very important when working in physics, and especially working with displacement time graphs. Here the unit, as always, is the vertical axis unit divided by the horizontal axis unit. So it's meters divided by seconds. The second part of the journey, what is the velocity? No calculations are necessary. Since it is a horizontal line, then the gradient is simply 0 meters per second. What is the velocity for the third part of the journey? Well, it goes from 5 down to 0. So that would be 0 minus 5. And then it goes from 10 up to 12.5. So that would be 12.5 minus 10. So working this one out, we get negative 5 divided by 2.5, which will give us a value of negative 2 meters per second. Since the line is sloping downwards, you should expect to get a negative value. If you do not get a negative value, then that means you are doing something wrong. So go ahead and try this one on your own, and then we'll check the answers in class. Have a good day, girls.